Well, as I have told in the previous part, Model 2 special assumes that the value of inputs are added to the outputs gradually, which means if a worker works 3 hours out of 10, 1/10 of the value is added. I mean 1/10 of the value of the output is created. So 15 labor hour worth of uh, table, if we talk on that, 1.5 labor hour of value of well, a table worth 1.5 labor hour is created when a worker works 1 hour out of 10 to add 15 labor hour to create a table with 15 labor hour worth. So if we assume that, then we can also assume the workers, when they work, they first add the value of the non-labor inputs. They create they create. I mean, when they create the output with value. First, they create sufficient amount of output with value, which is equal to the value of the non-labor inputs. Then they create a sufficient level of output which is equal to their own labor power, the value of their own labor power. So the value that is used to pay their wage. And lastly, they also create a value which is equal to surplus value, basically. So, for example, if they work well, for example, if they work 10 hours, if we have a table which is equal to 15 labor hour, in that case, and C is 5 labor hour, B is 5 labor hour, S is 5 labor hour, in that case, the 1/3 of the time is used to transfer C to the table. 1/3 of the time is created to transfer V to the table, and 1/3 of the time is created is used to create S, basically. Of course, in that case, if we have 10 labor hours, if the production time is 1 labor hour, in that case, C is transferred to the table in 3.33 labor hours. Let me write. I'm sorry. Okay, so 3,33, 3,33, 3,33. That's R, basically. Assuming production time is 10 hours. Note that, however, that doesn't mean that if the worker works 1 hour less, we only fail to produce the surplus value. So it doesn't mean that if production time is reduced by 1 hour, only 2 point. I mean, well, let's say we might assume when we look to this this picture, almost 1/3 of the surplus value won't be produced, which is not the case because the constant capital that is used, I mean, when you use 1 hour less, the constant capital you use is also less than the previous amount, since you use less input to produce table, you produce less table, so you will have some input, some extra input with some value left. So some C will be left. So you will need less time to transfer C with less value to the table. Similarly, since you work less, the less labor time work also less, which means you need less time to transfer this labor. This variable capital, this smaller amount of labor capital, to the table. So model 2 is not much use, so if it is really confusing you, you might just, well, study it, and if I have a question on it, there are multiple questions anyway. I mean, you won't need to, it won't be like you definitely need to know model 2. Maybe there might be a question where your knowledge on it might be useful, but it won't be detrimental to you. Not knowing model 2 won't be that bad. Actually, it is simple. I mean, it just may confuse you if you don't look to the right direction in case of model 2. Now, in order to make things a little bit easier and make you understand things better, let's assume the time necessary to produce table falls to 5 labor hours, value of which remain still 5 labor hour per 10 labor hour spent, which means, I mean, previously you needed 10 labor hour to produce one table. Now you need 5 labor hours, but since the workers still are likely to work full time, let's say they work for 10 hours and they produce 2 tables. So in 10 labor hour they produce 2 tables, but they which in total, they produce 2 tables basically, and they got a wage which is equal to 5 labor hour in return. What would happen in this case to our models? Let me write production time has fallen to 5. I told you that. Let me at first copy this. Well, I didn't mention any change of the input materials. So input materials are still produced in 5 labor hours. However, since production time now takes only 5 hours, less value is added to the table, which might at first sound a little bit surprising, since, I mean, being more productive is the value what you produce. But if you think about that, I mean, we are talking about social productivity. If the society becomes more productive in production of something, the social cost of producing that thing is cheaper. In that case, of course, the exchange value, which is representing the social cost, will be naturally smaller. We value things that are produced also, I mean, if you think about that, we value things that are produced in less time. For example, books at once needed a lot of time to produce, and their value was very high. Now their value, I mean, exchange value, the value you get when you sell a book, is much smaller. So since production time is now 5, exchange value is 5 plus 5, which is 10 labor hours. Note that the wages remain 5 labor hour per 10 labor hour spent. So in 10 labor hour, the workers get 5 labor hour worth wage. However, in 10 labor hour, they produce 2 tables. So per table, the wage paid is worth 2.5 labor hours, or 2.2,5, let's say. Again, I need to make this number. Well, out of 5 labor hour valid, I mean, the value of the table is 10 labor hour, C plus V is 7.5, so S is 2,5, which is very logical if you think about, production time is 5 labor hour, and basically 2.5 is spent to 2.5 of the value created in this 5 labor hours taken by the worker, and 2.5 is taken by the capitalist or the company, you might say. So what about this? Production time is now 5 hours, and half of the value that is created is basically directly transferred from the inputs. So half of the production time, 2.5, is done to reproduce the value of C. 1/4 of it is used to produce the wages or variable capital or the value of labor, and 1/4 is spent to produce surplus value, basically. Well, a weird thing might be happening here, basically. If you think about, we have improved our technology, however, surplus value per value created, the surplus value as a percentage of the value created has fallen. So does this mean for now, let's continue. We'll make a very important definition now, and then ask an important question. Since out of 10 labor hour work created, 5 is taken by the company, we might define a ratio that is equal to that we might call exploitation rate, which might be, well, it might be like this. It might be the total value created by the workers. I mean, the value taken by the company per total value created by the workers. If you do that, it will be 5/10, because total value created is 10. Value taken by the company is 5. So the ratio is 50%, you might say, basically. However, the more commonly used one is this one. And Marx uses this one in the Capital. So he just calculates the ratio, I mean, through the production process, what is the ratio of the value taken by the company divided to the value taken from by the workers. So here the ratio is 100%. 100% basically means that for each dollar of value created by the workers and taken by them, another dollar is created by the workers and taken by the company. And that ratio remains the same here, 2.5 or 2.5. It would not change if we had the other formula. I mean, still it will remain the same, basically. Note that S over V is not profit, even if the values and prices were equal, which they are not. But even if they were equal, note that the actual expense of the capitalists or the value of their inputs will be 10. So, and their revenue will be surplus value if their profit will be equal to S. In that case, I mean, for calculating profit, we should divide S to C plus V. Well, here we just want to see out of the value created, the value created through in the production process, how that value is divided, basically. And how this is related to profits, we will see in the next lecture.